Hello everybody, we're looking today at our section 1-13 notes. We're talking today about the inverses of functions, okay? And we start off with this definition right here with two blanks to fill in. It says that functions are inverses if they have the opposite domain and range of each other, okay? A function and its inverse have the opposite domain and range of each other. That's our definition that we're going to be using. So if we are finding the inverse of a function algebraically, we're going to follow these four steps right here. Okay? We're first going to replace our function notation, f of x. We're going to change it to y. And then what we're going to do, step number 2 is really the key to the whole thing. What we're going to do is we're going to swap the place. We're going to trade x and y in that equation, okay? And what that means, okay? We talked about it. We just said the definition of inverses is that they have the opposite domain and range. Well, if we're talking algebraically, domain and range are the x values and the y values. So what we do is in the function equation, we literally trade the place of the domain and range by swapping out x and y. Okay, after that, step number 3, you're going to see it's where most of the actual work is done. The other steps are really not pulling their weight, at least in terms of difficulty. You can see in step number 3, we're going to get back to where y is by itself. Okay, after we've traded places, we turn it back into a y equals something equation. And then step number 4 is just fixing the notation. Okay, so those 4 steps are what we're going to use on the first problems A, B, and C on the left side over here. Okay, so step number 1, let's start on it. Step number 1 is instead of f of x equals, we're going to make that y equals 4x plus 1. Okay, that's step number 1. Step number 2, pretty simple again. Step number 2, we're going to trade places of x and y. Okay, so instead of y equals 4x, we turn that into x equals 4y plus 1. That's step number 2. Step number 3 is where the actual work gets done. Okay, this means that we need to subtract 1 on both sides to get y by itself. We subtract 1 on both sides. That all goes away. On the right side, we have 4y. Make sure on the left that you're not trying to put these two things together. Okay, x and -1 are not like terms. So that means we can't have them put together as if they were like terms, okay? We have to keep them separate as two separate things, x minus 1. After that, what we're going to do to get y by itself is divide by 4. Okay, when we do it on the right side, that's pretty simple. We're left with y. But on the left side, you need to make sure that everything gets divided by 4. Not just the x, not just the -1, the whole thing all gets divided. So instead of x minus 1, I'm going to make that 1/4 x minus 1/4. If you wanted to make that 0.25 instead of 1/4, it wouldn't hurt my feelings. But after we get to where y is by itself, down here at the bottom, step 3 is complete. Okay, that is step 3, is to take our new equation and do whatever you need to do to get y by itself. Step number 4 is very, very simple. Step number 4 is to just fix the notation. Okay, we're going to change that y into f inverse. Okay, that's what that little symbol right there means. In fact, on the front page, you could go ahead and write that right there. Okay, this symbol is talking about the inverse of f. Okay, whenever you see that little exponent of -1, that's talking about that this is the inverse of the function f. Okay, so f inverse on this one equals what we just found, 1/4 x minus 1/4. That's the inverse of the original f that we started with. Let's try it again on part B. Okay, here on B, we start with 1/2 x plus 6. Well, step number 1 is to always rewrite that as a y equals. Step number 2 is to rewrite that with x and y trading places. Instead of y equals 1/2 x, we go x equals 1/2 y. That's step number 2. Step number 3 is where all the work gets done. Okay, we need this y to be by itself, so I'm going to subtract 6 first. That goes away. Remember, you can't combine x and -6. They're not like terms. Okay, what we see right here is kind of a weird situation because most of the time, if you have a number times the variable, you just divide by that number. Well, what happens on a fraction is when you're dividing by a fraction, it's the same thing as multiplying times the reciprocal. Okay, the shorthand way to keep track of this is that whatever is on the bottom of your fraction, whatever the denominator is, that is what you're going to multiply to get this thing out of the fraction. Okay, so we're going to take that 1/2 y, we're going to multiply times 2. Okay, this works because a fraction is just a way of writing division, right? So what's happening is right here, you're dividing by 2 and multiplying times 2 at the same time, and those two things undo each other. Okay, those two things are inverse operations. So all we're left with on the right side of the equal sign is 1y. Well, if we just have 1y, we don't actually have to write that coefficient of 1, right? So we can just leave it as y, and there it is. We've got y by itself. But remember your golden rule of algebra. What you do to one side of the equal sign, you must also do to the other. So if we multiplied times 2 on the right, we have to multiply everything times 2 on the left also. Okay? Instead of x minus 6, we have to multiply all of it times 2 and turn it into 2x minus 12. Okay, all that stuff in blue, that's step number 3. And we know step number 3 is complete because we have this y by itself. Okay, our last thing to do is fix the notation. Step number 4, we're going to rewrite as f inverse of x equals 2x minus 12. Part C. Okay, that business with the fraction, you're going to see how that comes back around here as we move along. Question C. Step 1, real simple. Step 2, real simple. I'm not even going to talk through it. We're just going to write it down and move on. Step 3 is where the work gets done. We got to get this y by itself, so we'll add 3. And now we have a fraction times the variable again. So just like we did before, what I'm going to do is I'm going to multiply times the denominator of this fraction. Okay, everything times 4. And what happens is right here, we're dividing by 4 and multiplying times 4 at the same time. And it all goes away. It undoes each other. We're done with that, and all we're left with is 3y. On the left side, when you multiply everything times 4, that's just distribution, right? It becomes 4x plus 12. Our last step, we still have to get y by itself. We're not done with step number 3 yet. We have to still divide by 3. Make sure when you divide that everything gets divided by 3, not just the 4x, not just the 12, not just the y. All of it gets divided by 3. On the right side is pretty easy. We've got it right there. That on the left is going to turn into 4/3 times x, and 12 over 3, well, that's just plus 4 right there. Okay, step number 3 is complete, so we finish it off by fixing our notation. F inverse of x equals 4/3 of x plus 4. Okay, so if you're finding the inverse of a function algebraically, you're going to follow those 4 steps. Oh, I guess I could write down that's step 1, step 2, step 3 was all of that in blue, and step 4 to finish it off right there. Okay, so there are some other questions that are related to inverses also, and I want to go over some of these because they're going to be on your homework and they're going to come up. You're going to be tested over some of this stuff too. Okay, our first question tells us on the right side, it's asking us to just find information, whatever information they're asking for, about the inverses. Okay, so this one tells us that on our original function, the domain and range are these sets right here. Okay, this one is the domain of our original, and this right here is the range of our original. And it's asking us to find the domain and range of the inverse. Okay, here's what I'm going to do. What I'm going to do is I know that the inverse and the original function have the opposite domain and range of each other. So what I'm going to do is I'm going to take the range from the original and rewrite it as the domain of our inverse. Okay, the only difference is that since it's a domain, it has to be x values instead of y values. Do y'all see the relationship of those two things that are highlighted in red? Okay, look at that. We've got the domain. It's all of the same numbers. It's just traded a domain for a range. And look at the same thing on the range of our inverse. Is going to be set up exactly the same way. It's still going to be all the numbers greater than 5. It's just going to be y values this time instead of x values. Okay, so y'all see the relationship between the domain and range of your original and your inverse. The two things highlighted in blue and the two things highlighted in red. They're the same sets of numbers, just repurposed for a domain and repurposed for a range. Okay, moving on to problem B right here. Okay, remember your definition of inverses, that they have swapped domain and range. When we looked at it in equations, step number 2 was that we literally swapped out x and y in the equation. Well, the same thing happens right here. We've got these points, 1, 2, 2, 6, and 4, 8 in our original function. The inverse function is going to have those same points, except with the x's and y's traded for each other. Okay, they have the opposite domain and range. So that means instead of the point 1, 2, we're going to have the point 2, 1. Instead of 2, 6, we're going to have 6, 2. Instead of 4, 8, we've got 8, 4. Okay, these are the points that are in the inverse. There it is. All right, so that's inverses. This should do a lot of good on your homework today. And hopefully we'll get you ready for that test coming up real soon too. All right, that's all we've got for today. Y'all have a good one.